today, and that is I study the flow of ice. I study how the Antarctic ice changes in time and try to predict how that's going to change in the future, with the consequences for sea level change, of course. And to do that, we use modeling. And the type of modeling that you'll be talking about and the interaction that you'll have today is very similar to what happens in glaciology. We have various ice sheet models in different parts of the world. They do different things, they're organized in different ways, they're based on similar understandings of the way physics of ice flows, and basic understandings of those, like the treatment of mathematics and structures are sometimes different to each other. What we do in glaciology is, on occasions, we come together, we try to unpack those models to see how they're functioning, to try to do intercomparison exercises and validation exercises as well, because that strengthens the type of research that we can get out. And I understand that's exactly the sort of thing we're doing today. So I know from my experience in studying ice, it's a very valuable thing to do, forming international links and meeting old friends is always worthwhile to try and do. So welcome to sunny London at the moment. Looks like it's slightly miserable now, it's a shame. But I really truly hope you have a productive couple of days, and maybe I'll see some of you most useful this. I'm going to hand over to Leo.
Thank you. Good morning. My name is Leo. It's good to see all these new faces again. I promise to say a few words and explain what this animal is, the Open Energy Modeling Initiative. That's surprisingly hard to do. Maybe the easiest way is to explain how it came along. It's exactly 1 year ago that basically a couple of friends and colleagues we gathered in Berlin because we all believe that the way energy economics research and energy policy advice is done today is not a good way. It's based maybe more in Europe than the UK, but it's all over the world based to a large degree on numerical modeling, on what's not well documented, that are not public, on data that's not clear, and on scenario assumptions that are not communicated. We all believe that both for research and policy that should change, and we should open up models and open source models, open data, and experimental assumptions that document. So we gathered in Berlin, 20 people without an agenda, just like sharing thoughts and like joining forces, and that's what came out of it. So what's the energy, the Open Mod Initiative? Well, it's basically what all of us are making out of it. And so at the moment, we are maybe a network of people who share ideas. We are a resource pool who exchange tools and competences. We are an advocacy group who talk to policymakers and push the ideas. All that, and it can be anything else what we make out of it. So there's no definition and nothing set in stone what we are. The initiative is a grassroots initiative. We haven't got a single penny of funding so far. We haven't applied for anything. It's all based on volunteer work. Anything you know, the website, the workshops, everything is set up by people who put in their spare time and resources to make it possible. First and foremost, for this workshop, by far the largest one that we had, one a year ago, and the spring workshop in Berlin. And now that's the third workshop. For this workshop, most of all, Stefan and Ian here and Ingmar prepared a lot of the work. Thanks to all of you. So what I just said about the Open Mod Initiative, that it's very much up to you what this is, the same is true for the workshop. Our idea of the workshop is that we kickstart the thing with a sort of classical format like presentation. This morning, set of presentations, however, we would like to have this really interactive, and we reduce the presentations to be very short. We have a little bit more than 1 hour for the presentations. They can be single or 2 or 3 slides each, not more than 5 minutes. So we have a lot of time this afternoon and the whole day for more for doing actual work. You're going to split up in groups, in parallel sessions that we call breakout groups, and try to get things done. We have proposed a few things. We have proposed a lot of things, a lot of groups, but this is all flexible and open. So if issues pop up, if ideas and questions pop up, please announce them and set something up, get people on, and get things done. That's why we're here. So we are flexible on what we do, but we're going to be strict on when we do it. Given the large amount of people, we're going to be very strict on time. The schedule is announced on the website, on the Wikipedia page that contains the brochure program and the regular groups and presentations. So we will be very strict and stick to that schedule to not lose time and get most of the space. Is there anything else that you would like to know as a background to the initiative? What we are, what we've been doing. We are recording the presentations here. Ingmar is head of video. If you feel uncomfortable having the presentation recorded, just let him know. It's at this moment live on YouTube so that those who couldn't join us in person are able to listen and see the presentations and discussions. The last two workshops, there were 15 to 20 people in the room, so we had an introduction round where everyone to explain who you are, where you come from, and why you're here. I think that's an atmosphere that's really good, and we would like to have that. However, given the large amount of people, we thought we should do this in a little bit different formats, not to spend the entire day for the presentation of people. What about this? Could maybe all people from Imperial, from our hosts, stand up and briefly introduce themselves, saying their name? Business School.
Richard Green, Business School, various things which mean I have a busy diary, so I won't be able to be here all the time. One of those is safety reps, so be careful on coffee cups and trailing wires, of which I already see lots and lots.
Planner of civil engineering. My name's Jared, and I'm at the Graduate Institute studying
So that's Imperial. Who's here for UCL? Last UCL. So who's from other institutions in between? Maybe just
Odin Cat from the Center for Renewable Energy Technology.
Lawrence, School of Construction Management and Engineering from Reading University.
I'm at the School of Engineering in Edinburgh, and I'm working on carbon capture storage.
Also from Women University, also from research.
thank you. Can I ask those of you who have been at the last workshops of either one?
In my first university father,
Clemens Railway, the DRW Berlin and TU Berlin.
Austin Mercury, Research Institute and
Daniel Huckman, also at the DOW Berlin.
Ja, das Dörfner, Technische Universität München, Munich, Developer.
So you know who was on the last workshop, and now you realize why we moved the workshop location from Berlin to London to London University. And I read that this works. Now, who has introduced yourself? Maybe just do this.
Dr. Womula from the University of Berlin. I'm Tom Brown, I'm interested in the grid integration for the energy optics. Sovereignty fund and starting University of Berlin. I am Brian from the Research Center in Munich. What the Bunker working for the European University Transport in
Hi everyone, I'm Charlie Keats. I'm from the Stockholm Environment Institute, but I'm actually based in Boston in the US. I'm mainly interested in energy modeling and climate mitigation in developing countries. And I developed a tool called LEAP, which is a tool for climate mitigation modeling.
I'm Sylvain. I'm working at the European Commission at the Government Research Center in close to Amsterdam. I'm Jody House.
All the University College Cork, Ireland,
I think Garland, University of Mexico, I'm working on the recently started
You did use energy overhaul Germany, working on power transmission network.
Great, I'm Olabila, I'm starting a PhD at the University of Senegal.
Great. We are ahead of schedule. Thank you for being here. I propose we just start immediately with presentations. The first mock presentation is remote via Skype. For those who present, we are roughly 12 people, so it's a rather long list of presentations. I will urge you to be short and to the point. This is not an academic conference format where you have to convince us that your research idea is great and you figured out how the world works. It's rather the idea of this sort of presentations is to give all of us a feeling on what kind of questions we work and what kind of models we use, what kind of data we need. So it's sort of a framing session to understand what we all are doing. Should we do it? Should we get started?
Yeah, so our Skype participant is right here. So I just probably you go first.
And could I just announce to anyone who's speaking, we have the red, yellow, green, yellow, and red system. You don't want to see what's on the red side. Yeah.
Okay, thanks. Let me see if I can stick to time. So I want to just tell you a little bit about the software we developed, and then I mainly wanted just to tee up some questions that I have for this group. I hope you can give me some guidance on what we should be doing in the future. So I'm the developer of LEAP, which is the long-range planning system. It's had a very long history. I've been developing it for more than 25 years now. LEAP is a very general purpose, sort of graphical, scenario-based integrated energy modeling tool. It's maybe different from some of the other models here, that it's fairly simple in terms of its algorithms, but it's a lot more about sort of data management, scenario management, and kind of visualization of results. But the modeling is actually relatively simple. It does support different methodologies, so you can do kind of, sort of engineering-based accounting of energy system emissions. You can do econometric modeling. You can also do some optimization modeling through links between LEAP and the osmosis model, which Mark is the main developer of here. Working on osmosis. LEAP is fairly widely used, so it's mainly used in developing countries, and it tends to be used by kind of governments who are trying to develop their climate mitigation plans. So a lot of countries are using their INDCs. You know what INDCs are? So that's kind of the intended nationally determined contribution. So it's basically the promises that countries are going to make at the Paris conference at the end of the year. So countries are using tools like LEAP to figure out what they're going to promise in Paris. So we do have thousands of users in basically every country now. But so far, LEAP is kind of, I guess I call it kind of semi-open. The source code itself is not open, but the source code is like, kind of think of it like, LEAP itself is like Microsoft Excel. So users of LEAP actually create models within LEAP, and those models are very open. All the equations are open, all the assumptions, all the data are very open. But the source code of LEAP itself is not currently open, and that's obviously something we're thinking about, something that we're considering doing in the future, and I'd like your guidance on it. So far, one of the reasons we haven't open sourced it is because no one's asked for it, and we don't really have very sophisticated users. I think most of the users of LEAP are kind of like energy planners or government officials. They're not hardcore modelers. So there hasn't really been that much demand for it so far. And instead of doing open sourcing, what we've done is develop an API so that it plays nicely with other tools. We haven't had to open source it. Okay, that's LEAP. That's one thing we're doing. So the second thing we're working on, we're only just getting started, but I just wanted to alert you to it, is developing this kind of open source, cloud-based environmental technology database. So LEAP has had kind of a technology database built into it, so it has data on different emission factors, costs and technologies, performance characteristics, but it's never been in the cloud, so it's not particularly useful in a sort of community sense. So we're looking to develop something that would be in the cloud, and we have an API so it could link to various different models. So that's something that we've only just begun working on, but we'd definitely like input from this group on that. Sorry, what's an API? Oh, sorry, application programming interface. It's a way for different models to communicate with each other. Sorry. Okay, so just wanted to flag that as something else we're doing. And then here's the main questions I have for you guys. Should we be open source or not? So, as I say, LEAP's been developed over many years, but the model we have at the moment is we give LEAP away free to developing country organizations, but we actually charge a license to OECD organizations, and we use the funds from that to subsidize the support we give to our users who get it for free. So what happens if we go open source? We have to give up on that funding model. Do people have any advice on that? Secondly, we have been working on kind of open data sets that we've been developing. So we've worked out with IEA and various other organizations that we can use their data and make data sets for LEAP that we can give to countries to help them get started. So that's something we'd also like to make much more open and accessible. I already mentioned that point. So some of the key questions I have for you is, what's the reasons that we shouldn't move to open source? Can you tell me good reasons? What would be good arguments I could use to my bosses why I should make it open source? Has anyone here had experience of taking a model that was closed source and making it open source? What experience did you go through in that? That would be really interesting. We're using a rather older programming language now. Young, high-tech people. So we use something called Delphi, which is rather old-fashioned now. Is that an issue, having an older programming language and making that open source? Is there any issue we should address there? And also, we rely in the software on many kind of plug-in components. So we have components that charting, maps. Can we have a piece of software that relies on all these commercial plugins still be open source? What would depend? And then I guess finally the question is, which is the best open source licensing model to go with in our situation? Do you guys have any advice on that? So I'll leave it to that.
No, I don't think so. But
Thanks very much for letting me slot in here with my presentation from here. It's much more convenient to do this from flight 24 hours to London, so it's really good. So I'm going to be speaking a little bit about a model that was developed by myself as part of my PhD at the University of New South Wales and is now getting wider use now that my PhD is finished. And I thought I'd just share my experiences with developing that model and what we're doing now that it's sort of more widely available. Next slide, please. So I'm interested in the slide with questions we're interested in, please, Stephen. Okay.
So my name is Joe Carlos. I'm an associate professor at Sept University, and I'm very happy to be here. I'm a very enthusiastic supporter of open source models, and I've been pushing for open source energy models for several years. So I want to give you a little bit of my perspective, and then also introduce Noah, field of energy model optimization and analysis, which is a So when I was setting up my research program about 7 years ago, I had already been doing energy system modeling for several years, and there were several things with the status quo approach to development and application that bothered me, and that I wanted to try and write through my own research. So the first thing is that when we use energy system models and we generate long-term projections, those projections are impossible to validate. And so what happens is we don't have tests that allow us to rein in efforts that might increase model complexity, but don't necessarily lead to more better insight. And so when you take the inability to validate results along with more data availability, better compute resources, I've seen a trend over time in going to conferences where the models are just getting more and more complicated, and many of them are also closed, and that produces two very bad outcomes. One is that we can't verify each other's results. So you go to the literature, you look at the results, but if you don't have the source code and the data, you can't possibly replicate what someone else has done, and I think that's a problem. Second, if we have large complex models, it makes them difficult to iterate. That makes uncertainty analysis more difficult. That's also a critical challenge because in these long-term projections, of course, uncertainty is everything. So we wrote a paper in 2012 where my students and I made an open call for more transparency in energy system modeling. We laid out a set of principles that we thought were worth trying to follow. And then we wrote a paper the following year that introduced our model to NOAA, where we tried to adopt many of our own recommendations. So what is TOMOA? Well, it's a bottom-up technology explicit model with perfect foresight. So if you're familiar with the Markell Times model generators or osmosis, it's similar in nature. You basically create a network energy system. All of the technologies within the system are specified with engineering economic parameters, and then you optimize the whole thing. You're minimizing cost, and you're trying to optimize the deployment and utilization of energy technologies. Our model, like all these models, it minimizes the present cost of energy supply. We also have flexible specification time slices, so you can divide the year into any number of daily slices as well as seasonal, so that you can match your time profile with the system you're trying to model. We also have variable length model time periods. So in the short term, you might want to set the model every, let's say, 2 to 5 years, where uncertainty is lower. But then in the longer term, where uncertainty is higher, you might want to set, say, every 5 years. We have technology vintaging, which means that for each technology, you can specify efficiencies and costs as a function of the model time period. We also have the ability to, you can see this, but technology-specific loan periods, lifetimes, and discount rates, which helps to increase the financial realism of the model. So why another model? Why another energy system model? Well, we developed it because we really want to address those issues that I mentioned earlier. We want to enable repeatable analysis, so we licensed it in GPL 2. Data and code is on GitHub, it's accessible by anyone, and we're using an open source software stack, so we pull in lots of tools, and all of those are open source as well. We also want to deal with uncertainty in a rigorous way, so we've designed the framework from day one to operate in a high-performance computing environment where we can take advantage of lots of computing cores, and the model currently has the ability to do stochastic optimization as well as to search for near optimal solutions, which give you additional insight into the possible ways forward. And then the third objective is we wanted something flexible. So it's all based in Python. We're using a Python-based package called Pynomo, which is developed at the National Lab, that allows us to formulate the model algebraically. And again, because it's based in Python, we're part of this very large open source Python ecosystem. And then this is just the final slide, just to give you an idea of what the capabilities are. We can visualize the energy system as a network using the open source tool called Rapid. If you see a little diagram there on the top right corner. We manage input and output data in a relational database using SQLite, which is a very free database tool. We We generate Excel output, which of course we often use. And we also use a configuration file. There's now a lot of different options that you can run the model with. And so being able to set that up in a single run file is useful. Project website and also a link to our GitHub account. And that's it.
Could I just suggest that if speakers want to be more than a profile, more than a silhouette on YouTube, stand this side so you don't get a very bright background.
Yeah, so data is open. I mean, right now it's whatever we develop is on GitHub, so you set up folders. I haven't quite figured out the data licensing, so I just set up a GPL version 2. I mean, that's actually maybe a topic for discussion, figuring out how to license the data. So is GPL the appropriate thing or create a common license? I don't know, I'm not a lawyer. I'm trying to work with folks in our university. It's actually sort of complicated. I definitely putting it in the public domain, but I don't know exactly how to license it.
Yeah, so I'm looking to know what doing something for research, and I'm looking to get our software or code called Sept. It's an open source implementation for the European network, and everything here that I'm about to say is open source data and code. So the idea behind Sept is that our department decided to do some tests, and we will try to search for the data. They work with the idea of applying this project. So what is Sept or Sept? So it's an open source reference. This is our aim. We want to be a reference model for the European Transition Network. If you're looking to brackets because for now we have it for Germany, but there are some issues with Europe. So why we want to do that is we want to have a deeper distribution at our level, improve data and more accessibility, modeling and transmission models are the backbone of the modeling. So how do we do that? We're going to go to the next slide. We have a fixed level knowledge, we have data extraction, implementation, then abstraction and export. And at the end, on the data looks like we have databases, and we also have some visualization. And the funding is from 3 ministries in Germany, which are research, economics, and education. The timeline, what we started almost a year ago, and we already had our first release in 2002. So the source code is open source, and the data is open source. And we have some, we are planning on some policy to organize a conference on benchmarking and evaluation. So this is the structure of the cycle. So cycle is based on OpenStreetMap, which makes people ask to make the data that results from the network free and accessible to everyone, so the data is accessible to the edge, and one has no choice but to license it again over the edge, so it's open for everyone. That's how the data is licensed as a matter. And then what we do is we take all this data that is in the OpenStreetMap, which deal with everything, and filter it for power. So we're filtering power, so we filter the data and extract it. Then we see some numbers that can vary, but since it's the order of things now, we use also osmosis, which is open source data code to filter the data, and this is to extract what we want from it. Then we export this power data to relational databases that is also open source tool for SMT, SQL. And for Germany, for example, it would take 2 minutes, and you would move 5 minutes. So then, after obtaining this data, which has the information about the geographical representation of the lines, the abstract to the network, and you can see that, for example, for Germany, the first distributed substations and the lines, which can be voltages and this sorts of discriminates. Then we export the data to different formats. You can use the example for partial or other. So that's basically the structure. And it was always an open source, so we have a web page where everything is listed. We have also some rules as a menu. It is also on the web page where we are now changing the version or it's a guidance about what we choose, what is coordination of the data to do what we want. And we want to post the meaning of the customer on the web page. And yeah.
Yeah, just a very short clarification question. You talked a lot about model in the beginning, but I think it's kind of confusing because most of our modelers, when they hear the word model, think of the optimization model, simulation models, but your work is actually about an open source project to derive data from OpenStreetMap to usable electricity data for our models, right? So that's, I think, to highlight the value of what you're doing. So it's not the data. Exactly. So.
Sorry? No, it's not something that's compatible, but our next step is to try to link to some other programs, some interface, but we're not sure it works now. So I'm here to check to see what is important.
The model in the European Competition Network and University of Edinburgh might do that. Do you know what the license is?
No, it's not open source. I mean, this is a bit. No, it's not. It's based on the SOA data, and it's not open.
You can download an Excel spreadsheet.
Yeah, but I think it's not open. But if you take an SOA map and you do what you want with it, then it's your problem after that what happens. And we will want that everyone can take this model, you have the list of the problems, everything is open, and it's guaranteed to do it. So the word is violated. This student took the SOA map and he took it to library using archives. And you can download it, but it's unlimited. No, for the moment we didn't. We are just at the first step of the model. But in the project, we are not going to follow but it's just to make the model ready for power.
Also, you can validate it.
Yeah. So you can validate it visually or just on the number of transmission lines and the number of substations. That's one validation. Say that you're looking for this, but the power level is not part of the project, but it's one of our interests.
Thank you.
Quick announcement between. So for the moment, we haven't planned any breakout groups regarding offshore modeling, networks, whatever. If people are interested, let me know. And there is more interest there, I can go into the fields. Question on model. I'm sorry, I'm not sure how to pronounce it.
That's okay, yeah. Okay. Yeah, my name is Owen McKenna. Thank you, Ian, for inviting me at the very last minute to talk about the Preston Man model version 2.0. So, what is it? It is a high-resolution, stochastic, bottom-up, integrated thermoelectrical domestic building model. Words there. Let's just expand on those. So it's a building level model. So I think there's going to be a lot of difference
type of models that the others presented. So here I'm interested in what's going on within a building and within aggregation of the building. It's an integrated thermal electrical model, so we do thermal demands, we do electrical demands within dwellings. This builds on version 1 of the model, which was solely focused on electrical. So what I've been working on is expanding that, extending that to well. It is bottom up, right? So it's all based on this kind of core representation of occupancy. And in terms of the type of data that it all hinges on, it hinges on time use surveys. So a large national databases or surveys of how people spend their time. And we can use that to figure out whether they're at home and what activities they're doing, and then that kind of percolates through the whole rest of the model. And that's pretty important for the type of research that I'm interested in, which are to do with impacts of low carbon technologies and demand side intervention on low voltage distribution networks. So a lot of the models that we're presenting are kind of top-down, national, or kind of pan-European models of big energy flows. The principal application for this is on the low voltage distribution network. You can scale it up to kind of, let's say, urban scale or neighborhood scale. So that's another application. Stochastic. So a lot of these models now use stochastic programming techniques in order to get kind of variability from between houses, diversity between houses, and so use kind of a Markov chain. What else? High resolution. So this is just an example. This is kind of a flavor of the type of output that we get. So we're talking about a period of 1 day here. This is for a single dwelling. Get some levels for aggregate dwellings, and we've got occupancy patterns of the dwelling. We've got demand. We've got this high resolution spikiness that is particularly important for local distribution networks. Temperature is going up and down. At the moment, it's just got gas boilers implemented, but obviously the interest is on the data requirements. It's important to kind of have data to calibrate the model. So things like large national data sets on buildings, the type of buildings that you get and feed that into your essentially low order models for building thermal demand. One of the things is that there's balance, we can strike a balance between complexity and computational efficiency. And I mean, kind of units of demand that I think what we may be dealing with are very lumped together, very aggregated, and it might be kind of top-down demand modules. So anyway, it's just to say that we generally use kind of low order. Developing these and trying to validate them, obviously using independent data sets, which is important to use this in costs, so we can have a comparison of model output with large national data sets. And then finally, what kind of software, do this all in Excel VBA, simply because it's very accessible and everyone is kind of good starting point for how people pick it up. At Crest, we've been developing models like this since 2008 and had quite a lot of picking up of the model. In fact, it's used in Germany quite a lot, especially in Right, so I think that's about it for me. Thank you very much.
for a little more than 10 minutes. Let's meet again at 11:10 and proceed. Before we proceed, there's 5 people that I would like to ask to come over for a second email. All not Charlie, Matt, and Guido. Let's see if I can
Emails.